Scientists have found that a thick layer of diamonds may exist hundreds of miles beneath Mercury's surface.
Astronomers and space lovers are in shock after discovering something genuinely startling about Mercury thanks to the James Webb Telescope. The most important mysteries of this small, burning planet have been kept hidden for years. What we now know is only the beginning. Mercury's mysteries are significantly more complex than the unusual. Shining spots that resemble diamonds that have been revealed in recent photos. What is the composition of Mercury's core? What additional mysteries could this strange world conceal that might even directly endanger humanity? The smallest planet in our solar system, Mercury, has long piqued the interest of astronomers and scientists. It was hidden from view for a long time until space travel technology advanced to the point where we could investigate it. NASA launched the Mariner 10 mission in 1973, and the Messenger probe was launched in 2004 as part of an ongoing effort to solve the mysteries surrounding Mercury. Investigating these discoveries further reveals much more disturbing information than we could have ever imagined about what's buried on Mercury, and this is only the beginning. The first spacecraft to visit Mercury was Mariner 10, which gave scientists a close-up view of this mysterious planet. Mariner 10 took pictures during its flybys that showed a terrain full of craters and peculiar, moon-like ridges. It demonstrated that Mercury is a complex planet with many craters, a stronger magnetic field than previously thought, and a larger core than previously thought. Mercury is not just a simple ball of rock. Scientists' preconceived notions about Mercury's composition were called into question by this revelation. A further mission named Messenger, Mercury surface, space environment, geochemistry, and ranging, was launched 31 years later, and it significantly increased our understanding of Mercury. Messenger, in contrast to Mariner 10, was built to orbit Mercury, enabling a far more thorough investigation of the planet. Messenger took an incredible 200,000 pictures throughout its journey, including hitherto unobserved regions of Mercury. The high concentrations of calcium and magnesium on Mercury's dark side were one of the most fascinating discoveries made by Messenger. Scientists began to wonder what processes were behind these high quantities. In addition, the mission found that Mercury's northern hemisphere possessed an exceptionally strong magnetic field, something not anticipated by scientists based on observations of other planets. These discoveries compelled scientists to reconsider the formation of Mercury and potential internal processes. Mercury has quite different magnetic behavior from other planets because of its unique inner structure. On planets like Earth, magnetic fields are usually caused by the movement of liquid iron within the core. The surface conditions of Mercury are similarly amazing. It can get as hot as 430 degrees Celsius, 806 degrees Fahrenheit, throughout the day, which is hot enough to melt lead. They can drop to a bone-chilling minus 180 degrees Celsius, minus 292 degrees Fahrenheit, at night. Mercury has a relatively thin exosphere, which does nothing to retain heat or regulate temperatures, which causes these dramatic temperature changes. In spite of these challenging circumstances, new study has revealed astonishing information about the planet. For instance, evidence of volcanic activity, including the remains of violent eruptions, was detected in 2012 by Messenger data. The fact that this discovery revealed Mercury is not as geologically dormant as previously thought astounded scientists. The revelation in 2020 that water ice is present in some of Mercury's polar craters, which are frigid enough to hold onto ice despite the planet's closeness to the sun, was even more unexpected. Scientists are now wondering if primitive life forms, like the extremophiles seen in some of the most hostile settings on Earth, could survive on Mercury as a result of this discovery. Bepi-Colombo, the most recent mission to Mercury, was launched by the Japan Aerospace Exploration Agency and the European Space Agency in 2018. It is scheduled to arrive at Mercury in 2025 with the goal of offering even more in-depth details regarding the surface, composition, and geological past of the planet. Mercury never ceases to amaze us with its strong magnetic field, unexpected water ice presence, and recent volcanic activity. What we are going to find out could be even more amazing. Mercury's peculiar motions only heighten the mystery surrounding it. Mercury is one of the planets whose year is shorter than its day. A single spin of the planet's axis takes an astounding 176 Earth days. Although it only takes 88 Earth days for it to orbit the Sun accordingly, a year on Mercury is equivalent to half of its day. If you were on Mercury, you would see the Sun rise, then seem to get bigger as it travels across the sky, stopping occasionally, making a small U-turn, and then carrying on. Because of Mercury's fast orbit around the Sun, its spin is unable to keep up, resulting in this strange motion. Scientists think that tidal locking, in which Mercury's rotation has been progressively slowed down over billions of years by the Sun's gravity, is the cause of this slow spin. Unlike our Moon, which is totally tidally locked to Earth, Mercury is not. Rather, it rotates 3 times for every 2 orbits around the Sun due to a 3:2 spin-orbit resonance. Due to Mercury's unusual spin-orbit relationship, one side of the planet experiences great heat for extended periods of time, while the other side is plunged in icy darkness. Mercury has a very thin exosphere, which is made up of gases that constantly leak into space and are refilled by solar wind, nuclear decay, and impacts from space rocks. Despite Mercury's closeness to the Sun, studies conducted in 2020 with MESSENGER data showed that Mercury's exosphere had more water vapor than previously believed. This water vapor is most likely the result of a reaction between oxygen in Mercury's surface rocks and hydrogen from the solar wind. Unexpected characteristics of Mercury keep testing our knowledge of planetary science. For example, despite the planet's small size and sluggish rotation, its magnetic field persists, but it is less than Earth's. Mercury's core's liquid metal flow is what creates this magnetic field. With the core making up over 85% of the planet's volume, as opposed to merely 15% on Earth, it is thought that the planet's core is very big. This shows that Mercury might have experienced a violent past, possibly resulting from a large impact that removed most of the planet's outer layer and left behind a dense core that is rich in metals. Other elements found on Mercury's surface include sulfur, potassium, and sodium, all of which evaporate at high temperatures. This 2020 discovery raised the possibility that comets or asteroids may have brought these elements to Mercury. Furthermore, the discovery of water ice in Mercury's polar craters, which are continuously shaded, begs intriguing issues regarding the likelihood that organic substances may exist there. Mercury is not merely a rock circling the Sun. Far from that, Mercury is geologically active, according to evidence from recent missions, especially MESSENGER. Mercury's surface has small, shining spots called halos that point to continuing geological processes and the possibility of further evolution. Scientists examining Mercury's chaotic topography, a sizable area full of tangled hills and valleys, hypothesize that this disordered region may be the result of intense tectonic activity brought on by the Sun's gravitational pull on Mercury's orbit. The MESSENGER mission has contributed to our understanding of Mercury's intricate interior structure by demonstrating that the planet has a sizable solid inner core surrounded by a majority of its liquid core. With a radius of around 1,260 miles, Mercury's inner core makes up almost half of the planet's overall core, which is significantly larger than Earth's. The distinct interior structure of Mercury affects the surface geology and adds to the planet's magnetic field. Furthermore, in 2012, MESSENGER detected what are known as halos on the surface, which were probably created when volatile elements leaked into space. 2020 saw the discovery of evidence pointing to the existence of an ancient magma ocean beneath the surface, which shed light on Mercury's early geological past. The most stunning finding was made in 2022 when scientists discovered evidence of trapped nitrogen below the surface. This finding raised the possibility that Mercury's heavier atmosphere was originally driven underground by strong solar radiation. Every new discovery made by Mercury poses new problems and challenges our understanding of the solar system. Mercury, a planet that is frequently disregarded, is essential to comprehending the creation and development of planets. Its varied geological characteristics, harsh environment, and undiscovered mysteries never cease to enthrall scientists and space enthusiasts. We are left to wonder what more this small planet might be hiding and what mysteries it might be able to disclose about the biggest mysteries in our cosmos as we look to upcoming missions and continued research.